Chapter 3. The Basic Ingredients of Network Management. Chapters 1, Setting the Stage, and 2, On the Job with the Network Manager, explored what network management does, why it is important, where its challenges lie, and what kinds of activities and tools are associated with it. But what does network management at a very basic level really consist of? First, there is, of course, the network that is to be managed, consisting of a multitude of interconnected devices that collectively shuffle data. For example, web pages, emails, voice packets of phone calls, and video frames across the network. Second, there are the systems and applications that are used to manage network, many of which are described in Chapter 2. Third, the network that is to be managed and the managing applications must be interconnected so they can communicate with each other. Network management itself is a networking application which creates an almost paradoxical situation. After you have read this chapter, you should be able to do the following. Explain the terms manager and agent. Second, describe what management information bases or MIBs are about. Third, explain how management agents, managed devices, and MIBs relate to each other. Explain the difference between in-band and out-of-band management communications. Fourth, state the pros and cons of dedicated management networks. And lastly, describe the role of a network center or NOC. The network device. The first main component in network management consists of the device that must be managed. Of course, in general, there will be not just one but many devices. In network management parlance, we also call the managed devices network elements or NEs. To be properly managed, they must participate in the management process. Management agent. To be managed, a network element must offer a management interface through which a managing system can communicate with the network element for management purposes. For example, the management interface allows the management system to send a request to the network element. This could be, for example, a request to configure a sub-interface, to retrieve statistical data about the utilization of a port, or to obtain information about the status of connection. Manager-agent communication. Manager and agent are important terms in network management parlance. They refer to the systems that manage or the manager, and the systems that are managed, which are the agent. Client-server is another well-known asymmetric communication relationship that the reader might already be familiar with. Therefore, a few words of the relationship between manager or agent and the client or server are in order. Manager-agent versus client-server. Network elements must provide a piece of software that implements the management interface. This software effectively provides the intermediary between external manager and the managed device. We refer to this software generally as the management agent. In fact, this means that we are slightly overloading the term agent. Agent is used to refer both to the agent role that a network element plays in network management and to the software component called the management agent. The management agent conceptually consists of three main parts: a management interface, a management information base, and the core agent logic. The management interface handles management communication. The management interface supports a management protocol that defines the rules of conversation for communication between the managed network element. The management information base or MIB is a conceptual data store that contains a management view of the device being managed. The conceptual data contained in this data store constitute the management information. Management operations are directed against this conceptual view. The core agent logic translates between the operation of the management interface, the MIB, and the actual device. For example, It translates the request to retrieve a counter into an internal operation that records out of a device hardware register that contains the desired information. In fact, many counters of the same type might exist inside the network element. For example, one per communication interface. Anatomy of a management agent. Although a network element plays only one agent role, it can actually contain several management agents, each with its own management interface. Just as different views can be defined on the same underlying database, each management agent can offer its own MIB, that is, its own abstraction of the underlying network element. A network element can provide different management agents for the number of reasons. One common reason is to give management application a choice of management interfaces. Another reason is that the different management agent might serve different functions. For example, one management agent might be dedicated to reporting performance statistics through a special interface that is tuned for the particular purpose, whereas another management agent might be dedicated to configuring a device offering a different kind of interface for that purpose. Management information, MOs, MIBs, and real resources. In general, many aspects of a network device, such as a router or a switch, are important for its management. For example, the device's network address. It is of a certain type and it has software installed of a certain revision. If the device is a router, it might be running a variety of routing protocols. The device might consist of a rack-mountable chassis with a fan for cooling, a central processor for module, and a set of expansion slots. All these aspects exist independently of whether the device is being managed. The version of installed software must be remotely determined to decide which devices need to have a new software patch installed. Utilization of ports must be assessed to determine whether capacity upgrades are necessary or whether surplus capacity could be redeployed. Environmental data is monitored to determine temperature and voltages to ensure that a device is not overheating. Fans are monitored to help remotely determine what is causing device temperature to rise. Packet counters for different interfaces must be monitored. For example, sudden jumps in certain types of packet counts could indicate that a network is under a certain type of attack, such as so-called denial of service or DOS attack. Protocol timeout parameters must be configured to fine-tune network communication performance. Firewall rules that define a security policy must be configured. For example, discard packets of a certain type unless they originate from an address with a certain prefix. Different abstractions of the same real resource. The collection of all management information that is exposed by a network element to managing application is referred to as the Network Element's Management Information Base or MIB. The concept was mentioned in the previous section, but because it is so central to network management, it is briefly revisited here. The MIB constitutes a conceptual data store, an abstraction that contains all the information that management applications need to know about a device. In essence, a management application can treat the MIB like a conceptual database that contains the data about the network element. This database can be queried for information, and as far as the information represents configuration information that is subject to be changed by a manager, the conceptual database can be modified, inserted, and deleted. Basic management ingredients revisited. Now that the notion of real resources and the distinction between the network device and the management agent is in place, we can briefly revisit our original picture of the basic management components to include the distinction. At the most basic level, there are only two components depicted at the top and the bottom: the network provider's operational support organization and the real world that it wants to manage. However, Technical means are required to connect the operational support organization to the real world, and that the connection comes through the management technology. The management agent acts as a proxy that represents the real world for a management purposes. Likewise, the management systems acts as a proxy for the operational support organization. Management interfaces and the protocols defines their rules of engagement. Communication between them is carried over a management network.
Now I'm going to discuss about the management system. Management systems provide network providers with the tools to manage the network. These tools include applications to monitor the network, service provisioning systems, craft terminals, and so forth. A management system can run on one or more hosts. That is, it can be distributed across several hosts. It can make the system also more robust, meaning even if one host fails, the system can still keep running. Management system and manager role. There's a difference between management system and manager. A manager is the role, while management system is the application. This is because for various reasons, it might make sense for the same system to play both agent and manager roles. For example, one network element might act as a management proxy to another. In this case, the network element plays the agent role in interacting with the management system, but it plays the manager role in interacting with the other network element. As you can see in this figure, two management systems might be part of a management hierarchy, with one management system directing management requests at another, which then turns around to pass on the request to a third system or a network element. In that case, the management system in the middle acts in an agent role when it receives management requests from the first management system, in addition to playing its more conventional role of manager with respect to the network element. To provide their functionality, management systems must communicate with the network elements they manage. In the communication that takes place, management systems assume the manager role. This next figure, it illustrates how a manager and agent relate to each other. As you can see, there is the managing system, which is the manager, and the managed system, which is the agent. There is also a MIB, or Management Information Base, which is a conceptual data store that contains a management view of the device being managed. The MIB always resides with the agent, as shown on the second figure. For efficiency reasons, many management systems build their own database in which they cache information about the network. They do this to avoid having to go back to the network element repeatedly for the same information. In this third figure, there is a shadow MIB on the managing system, but actually, the real MIB resides with the agent. The purpose of an agent is to provide a representation of a real-world entity that is to be managed. The management agent can be considered to be a proxy for the managed device. As far as the management system is concerned, the management agent is the managed device. Similarly, as far as the managed device is concerned, the management system in effect serves as a proxy for the real-world organization that is responsible for managing the network. A management system's reason for being. A management system exists only for the purposes of network management. It simply means that a management system is used for the organization, maintenance, and monitoring of your network. Management system is important because if you lose your management system, the problems on your network cannot be detected and fixed quickly.
The management network. Now, we understand that managers and agents refer to different roles in which management systems and network elements communicate with each other for management purposes. But how do they communicate? The answer is over a network, of course. At the end of the day, network management is just another distributed application. The different systems that need to communicate in this case just happen to involve management systems and the network elements that they manage. Managing systems and managed systems need to be interconnected. The network that provides this interconnection is referred to as the management network. In contrast, when referring to the network that carries the traffic of subscribers and end users, we use the term production network. A management network and a production network can be physically separate networks, or they can share the same physical network. For the network element that is being managed, one important difference between management traffic and other types of communication traffic is that management traffic is one of the few types of traffic that involve the network element itself. Here, the situation is different. The network element itself is one of the participating parties in the communication where traffic is terminated or originated. It is not merely a point of transit. Networking for management. One way in which network elements can be connected to a management system is through the network elements management port. For most routers, this is a serial interface. As illustrated in Figure 3-10, or connecting to a CRAF terminal to a managed device, it is possible to connect a terminal, such as a notebook computer, directly to the serial interface using a serial cable. The terminal thus connected to a network device is typically referred to as a CRAF terminal, in reference to the CRAF technician who typically uses it. The CRAF terminal then functions as a console through which a user or a CRAF technician can interact with the device. For example, the CRAF technician can enter CLI commands to configure and troubleshoot the network device. If you are a CRAF technician, in most cases, it soon becomes impractical to go from device to device, connecting and disconnecting the CRAF terminal as you go along. You need to continuously fumble around with the plugs and the cables, or worse, you need physical access to the network elements and must work on in spaces that can be quite confined. For these reasons, a terminal server can be introduced. As illustrated in Figure 3-11, or connecting to multiple devices through a terminal server, the terminal server has a whole set of serial interface ports through which it can connect with many network elements simultaneously, one through each port. In addition, it has a port for the CRAF terminal to connect to. You can connect your CRAF terminal to the terminal server to connect to every device that is hooked up to the terminal server. When connecting, your console initially opens a session with the terminal server. You can then specify which port you want to be switched to. From that point on, the terminal server relays all communication between your CRAF terminal and the network element connected to that port. Thus, you can communicate with the network element behind the terminal server's port, just as if you were directly connected through its console port. The terminal server, as you can see, takes the place of an intermediate switch between the actual CRAF terminal and the network element. To make matters even better, the terminal server also has an IP address and an Ethernet interface. This enables you to connect to the terminal servers through a network, such as a local area network or LAN. It is necessary to keep track of which network element is connected to which terminal server and through which port. It is easy to lose track of this information, especially as the number of network elements, terminal servers, and thus complexity of the management network grows. The second method of connecting to a network element is through its Ethernet port. Most network elements offer such a port through which they can be addressed directly from the network. The network element does not use the port to route traffic. The network element uses it to attach a network like any other host. Instead, it has its own IP address used for management purposes that allows the network element to be treated and addressed like any other host on a network. The third method of connecting to a network element is to simply use a port that is shared with other traffic. Traffic that does not terminate at the network element, but that is routed or switched. In this case, management traffic is carried in band instead of out of band, as with other options. The pros and cons of a dedicated management network. Carrying management traffic out of band can quickly result in building a fairly sophisticated network that is dedicated just to network management. A dedicated network that allows your management systems to communicate with the network elements that they are managing. As the figure 3-12 shows, or the dedicated versus shared management and production networks, in figure 3-12A, it depicts the two alternatives of having a network that is shared for both management and production traffic. Whereas in figure 3-12B, it keeps the management and production networks physically separate. Which option makes the most sense? The answer is, it depends. Like so much in engineering, it is all about trade-offs. The advantages of using a dedicated management network are numerous. First is the reliability. With a dedicated management network, management traffic is carried independently of traffic over the production network, making management significantly more reliable. For example, picture a situation in which a network failure or network congestion occurs and makes a certain segment of the network hard to reach. In this situation, management is absolutely critical to finding out what happened and possibly to subsequently instructing the network to perform certain reconfigurations to remedy the situation. However, unless you have a dedicated management network, chances are management traffic will be just as incapable of getting through as any other communications traffic. As with an ambulance that is stuck in traffic, you will not able to get to the scene easily to determine exactly what was happened. This means that the management might effectively be unavailable just when it needed the most. Of course, with a dedicated management network, all of this is non-issue. Second is interference avoidance. When carried over the production network, management traffic competes with the other networking traffic. This includes data application traffic, as well as traffic with high quality of service requirements. Interference between management and production network traffic can also make certain problems harder to diagnose. Again, with a dedicated management network, all of this is non-issue. Third is ease of network planning. Avoiding interference as described in the previous bullet requires careful networking planning that takes into account the effects of unpredictable network management traffic. Network planning for the production network becomes easier if there is no need to consider management traffic, as is the case when a dedicated management network is used. However, a dedicated management network runs only a single application, network management. So, this problem becomes simpler. And last, the security. A dedicated management network is harder to attack and easier to secure. End users and subscribers will never come into contact with it. Its devices are on a completely separate network. This makes it less prone to hackers and less vulnerable too. On the other hand, there are a variety of reasons not to use a dedicated management network and to use management communication exchanges over a shared network. The first is the cost and overhead. Despite its advantages, a dedicated management network requires a separate network to be built. This comes with a huge price tag that results in significant additional cost. A shared network does not require additional devices, additional space, and additional cabling. Second is no reasonable alternative. In quite a few cases, a shared network might realistically be only option. For example, equipment that is deployed at the customer premises might be reachable only through one network. One scenario involves a digital subscriber line or DSL router that is located at the site of a customer. The service provider provides DSL connectivity to this router, but it does not make sense to provide separate management connectivity. Instead, any required management communication occurs over the same physical network. Of course, at the logical level at least, a separate channel can be used. What about management of the dedicated management network? Shouldn't this be a consideration as well? Will we now also need a management network to manage the management network as well? And who would manage that? The answer is that the management network will also provide management connectivity for its own devices. One management network is enough. In summary, a dedicated management network has undeniable advantages for areas of a network in which management is critical. For example, the backbone at a service provider or even a large enterprise. This is the implementation of choice.
The Management Support Organization. In this section, we briefly discuss some of the non-technical aspects. You can think of the organizational aspects as a separate problem dimension in network management. This dimension exists in parallel and in addition to the technical dimension. Managing the management. The Management Support Organization ultimately is responsible for making sure that the network being run effectively and efficiently. It performs tasks such as monitoring the network for failures, observing the network frequently to make sure there were no failures, diagnosing failures and communication outages, provisioning new services and adding and removing users to and from the network, keeping an eye performance of the network, taking preventive measures when service levels appear to slip, and taking note of early indications when, for example, the network is running low on communication capacity. Planning network upgrades, such as installation of new line cards to increase capacity or distribution of software patches. Planning network topology and network build-out. This is to ensure that the network will continue to meet future communication demands. One way of structuring the management support organization involves analyzing the different tasks that must be accounted for and the workflows that they involve. The organization is then divided into different units that each perform a distinct function, taking into account workflows to minimize interactions that are required between different units and specifically dependencies that might lead to finger-pointing situations. Responsibilities of the different units and the organizational interfaces between them, procedures, and workflows must be clearly defined. For example, one way to structure organization might result in distinctive organization units for the following. Network planning, responsible for analyzing network usage and traffic patterns and planning network build-out and service rollout. Network operations, responsible for keeping the network running and monitoring the network for failures. Network administration, the only organization allowed to actually physically touch the network, responsible for deploying the network and services on it. Customer management, responsible for interacting with the customers. This group takes orders for new services and provides various forms of customer support. Each of the organizations has its own personnel, with their own distinct roles. The most generic term that describes the role of a staff member is network operator, but this term includes such network operators, network administrators, network planners, craft technicians, service order operators, workforce dispatchers, customer support personnel, and many more. In addition to a good organizational structure and clear network management responsibilities, many other things need to be considered to be able to run the network smoothly. These include, but are not limited to, the following: establishment of process and operational policies, documentation of operational procedures. This helps make management of the network consistent and efficient, and facilities meeting a consistently high standard of operations. One aspect of this is well-defined workflows to make sure that things that are supposed to happen do not fall through the cracks. Another aspect concerns well-defined escalation procedures to ensure responsiveness. Next is collection of audit trails. Automatically logging the activities of operation support staff who initiated what action at what time makes it easier to reproduce what happened and recover from situations in which human error or omission led to operational hiccups. Network documentation. Make sure not just your procedures and policies, but also your network itself is well documented. That is, documentation must be accurate and up to date. This is important for activities such as network planning and the planning of software upgrades. It also enables you to identify discrepancies between what is supposed to be in the network and what actually has been deployed. Then, reliable backup and restore procedures. This provides your network operations with an invaluable lifeline that lets you bring the network backup in case of disaster and emergencies. If you cannot immediately figure out what's wrong, the best source of action might be to restore the last configuration that was known to work properly. Last is the security emphasis. Security threats in networking have received a lot of attention in recent years. The most significant threat to your network might not be hackers from the outside, but disgruntled employees on the inside. On the inside, employees have physically access to the network equipment as well as to the tools to mess with it. Hence, your network is potentially most vulnerable from the inside. Therefore, in addition to keeping your operations staff happy, make sure that the amount of damage that any one person can cause is limited and can be recovered from. Network Operations Center or NOC. The place from which large networks is managed is generally termed the Network Operations Center or NOC. In addition, the NOC might house the communications equipment itself. Communications equipment is often housed in rooms that are filled with large floor-to-ceiling racks in which network elements are mounted with their leads blinking and masses of wiring and cabling coming out of the back. Cabling, in fact, is another issue that can quickly become a problem. For a large and global organizations, a central NOC might not be enough. In those cases, several NOCs acting as peers that can back up each other up if required are introduced. When the sun sets
and it is time for the local personnel to go home. The responsibility for running the network is handed off, and the next knock, where the sun is just rising, takes over. Obviously, to be realized successfully, sophisticated organization, procedures, and operational policies are required, along with the stringent requirements imposed on management system to support them.